Okay, we'll check this sum out. There are two interesting parts in this sum. 2014 Jan, question 18. Tugboat is towing an iceberg. Okay. Three-body force diagram is labeled. Upward force is upthrust. Then this is the iceberg, no? So that's a tension. Forward force will be the tension, resultant tension by the two ropes. Resultant tension by the two ropes. Okay. Okay, just tension also fine by the examiner, but better resultant tension by the two ropes. This is laying the foundation for something coming in the sum. These two tension, there's a resultant. Resultant tension will be T cos 15 plus T cos 15, 2T cos 15. These two, they don't mark like 2T cos 15 for the later part. I'm talking about this. Done. So you mark the forces. That is okay. Next one, the iceberg is moving at a constant speed. That tension in the two ropes are equal. Of course, we know that. Show that tension in the bisymmetry. We know that by symmetry. Bisymmetry. And if the diagram forces all the forces are in symmetry here, so tension will be equal. Okay. Drag force from the water. So this is equal to 2T cos 15 should be equal to drag. 2T cos 15 is equal to drag. So it will be, which is that? Okay, 2T 3.3 into 10 to the power 5. That's okay. These are easy parts. Don't mark forces like this. U, T, don't mark like that. Name the force. Resultant tension is better for the forward force. Upward force is upthrust. Pull by the tugboat also allowed. Calculate work done by the tugboat on the iceberg being pull 50 kilometers. Work done is equal to force into distance moved in the direction of the force. So the forward force will be 2T cos 15 into 5,000. 5,000, that you can get the answer. Answer will be 1.93 into 10 to the power 10. Now, this is the interesting part. State and explain the effect on the motion of iceberg if the two ropes were longer, assuming that the tugboat power output remain the same. So now this is what will come. This is like a dusra or a googly. Examination like that. Every day they'll bolt the off spin, off spin, off spin, off spin, suddenly leg spin. Okay. So now we must get prepared for this as well. We'll take malinga. So we'll say out swinger, in swinger, bouncer, 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 yoker. Oh, this is the yoker. Now, what's every day something? This is what will come across your mind, and this is the answer you will be writing. Now, you might have done the suitcase sum. Suitcase sum. You are applying a force. Handle become longer. This angle is 30 degrees. This tension force is 30 Newton. Okay, then the horizontal component is, we'll make it different, 40 cos 30. 40 cos 30. Okay, then now we say handle became long. Of course, when the handle became long, angle will become smaller. More horizontal component of the force. If there was acceleration there, it will be higher acceleration than that. Is it 20? Even if you apply the same force, is applying the same force, 40 Okay. So now the horizontal component will be 40 cos 20. No? More force that way, no? More force that way, cos 20. I will give you the difference. 40 sine 40 cos 40 cos 30. That is 34.64. That one is 40 cos 20. 37.5. Correct, no? 37.5. Greater horizontal component. Greater acceleration. Okay? If you move the same distance, greater horizontal work is done. Now, some questions they ask why there is no vertical work done. Vertical component is there, but vertical no distance moved in the direction of the vertical direction. And you may have done the two horses sums. Similar. Two horses are towing like this, okay, but not the tugboat. Two horses are like this. Later, if I have time, those who come across this sum, again, same. This is also same answer. Two horses are there. Same story. Longer rope, more horizontal combo. Other one is the lawnmower. Lawnmower. The other one is the this food city carts that also was there. Lawnmower. The handle was horizontal, not an angle. Then full force. There is no component. Full force is set in that. First part or something, handle is at an angle. We'll come back to this question. Now it will come across to your mind straight. Hmm. Longer rope, low angle, more force. It's in motion, so it will move with a higher speed or it will move with higher acceleration. That's not the answer here. Why? Look at the diagram. Not like the horse sum. Look at the diagram. You know, power is equal to force into velocity. You know that equation. How did I go? So if you know it better, extend if the motion iceberg along, assuming that the both power would remain the same. Okay, then that's when this forward force, whatever it was the same. You see, this is 100 Newton. If this is 100 Newton, now we say this is 30. We take the equilibrium of, I'm doing it in detail because this is the yoke. Most of the time that's the sum. Most of the time that's the other sum. So now you can see 2t cos 15 is equal to 100. Equilibrium of the tugboat. 100 is equal to 2t cos 15. What's the force acting on the iceberg? Iceberg also 2t cos 15. We did that working there. Now we'll make it long and see. If I make it long, now the angle will be small. We'll say the angle is 20. Okay. Now what's the force acting on the iceberg? It's a new tension. It's not the early tension. It's a new tension. It's a T dash. What's the force acting? 2t dash cos 20. Now I want the angle lower, so the cos 10 will be cos 10. Cos 10. Now we'll go back to the tugboat and see. It's 100. So can you see in this situation, the forward force acting on the iceberg did not change by changing the angle. All the other sums, that's correct. These are rare sum. Every around 7, 8 years only this will appear. For 2040, is 2024, no? 10. Okay. If this one, be careful. Did you see that? The reason there's a forward force on the tugboat. You have to balance it and see. So what will be the answer? The net force acting on the iceberg will remain the same. All the tension is low. Okay, net force acting on the iceberg is still 100. Okay, but if you tension will change. It does not matter the net force acting. In this case, net force acting, it will remain the same. So it will move with the same constant speed, no change. Okay. So this is the answer. I'm showing the masking to confirm it. The same speed, no effect to the motion. Okay. You can say tugboat exercise same forward force 100. Yeah, tension in each of the pieces, that's fine. Now, if you want, you can mention that. Okay. But this is enough. You got that, no? Tension will change actually. Tension will change. T dash is not same as T. Did you understand? Then I'll go back. This is the difficult version of the sum. We'll hope this won't appear this time. Let's get ready for that. There's another part. This is okay. Tugboat is moving through the water. Due west this way 2.6 centimeters we can take. Check your scale also say 1 centimeter is equal to 1 kilometers per hour. Then due south, downward 0.9. We have to join them head to tail. So what we'll do is we'll take 2.6. Okay, if you want, you can double it. Double 2.6, double is better. No? So there's scale is a larger the diagram, lesser your percentage answer, lower the percentage answer. Therefore, we'll double it and go. No, 2.6 when you double it by 2, 5.2. I can get 5.2 boxes that way, 5.2 boxes that way. 1, 2, 3, 4, 5.2. 0.9 double 1.8. Can triple also. See whether if you can triple, do it like that. 1.8. Now when I join the starting point and the end point, I'll get the resultant. When I join the starting point and the end point, I get the resultant velocity and the direction. There's a bit below vertical and scale data, magnitude and direction of resultant velocity of the tugboat. So this is the magnitude. Measure it with the rule. What you have is the ruler. It has a zero error. But when you write answers, always refer to the word rule. The metric rule, it does not have a zero. The edge part is not there. Then it's done. Next part. Not all of the iceberg is visible above the surface of the water. Show that the proportion of the volume of the iceberg beneath the surface of the water. So two forces are balanced. Upthrust is balanced by the weight. Upthrust is acting upward, balanced by the weight. Both are equal. Upthrust is equal to B. B means the volume of the liquid inside the water, this part volume. Volume of the water displays, or volume of the liquid displays. Volume of the liquid displays. So we say volume below. And they're asking a ratio. We know, normally people also say 1/10 of the iceberg only can be seen on top. Okay, then V rho G, rho of the liquid into gravity. Weight depending on the sum, there are many equations. No, weight is equal to, I can say, mg. But in this case, I know I can write V rho of the solid into gravity. That's also correct. The density is equal to mass over volume. So I'll write for this sum, not this equation, not the everyday one, because I want to get the ratio. I'll write in the place of mass, can you see in the place of mass, I can write rho of the solid, volume of the solid. So I'll write in the place of, I'll write like this mg, then after I can that for the exam also 300. In the mass place, I can say V of the solid, rho of the solid into gravity. Still equal. It's in equilibrium. Say it's in equilibrium. Opposites are balanced. V below, rho liquid, G is equal to V solid mean V total, total volume. V total, rho solid into gravity. You can say G only will cancel off. So I need the ratio of we'll take it as V below, we will divide by V total. That's what I mean. V below divide by V total will be equal to rho S divide by rho liquid. Rho solid is 920 divide by 1030. 20 divided by 1030 0.89. 0.89. It's a ratio, no? It's done. But always get referred to that earlier one. Normal answer. I'm talking about the early. If the rope is longer, the angle is less, more horizontal compound. But rare occasion, these tricky questions are there. A yoke. Okay. Then we'll see you next time. Think if it is not clear, ask me in the next class.